So I'm currently working as a software architect and a data scientist. So I've been working like 9 plus, so close to 10 years of experience in the industry so far. And for the majority of that, I have taught as well to various students. So I've taught machine learning, software architecture, and programming to various students. So till date, I have taught 1,000 plus students with various backgrounds. So I've taught students in colleges. I've taught working professionals who are either trying to like excel in their current job or maybe change jobs as well. So all this to say that you're in good hands, and like that's what we want you to sort of feel from all of this. Now, coming to the topic that we have for the demo, obviously it's a demo about AI, ML, and data science, and we saw that majority of the folks that showed interest in joining these classes and even registering for this demo are beginners, are in that vicinity of like maybe beginners. So we picked a very introductory topic to sort of get everyone on board and make sure it becomes easily understandable for everyone. And that's what we'll sort of cover. So we're keeping it very beginner friendly. So if this is something you're maybe already familiar with, hopefully this will be a good recap for you. And for all of others, we're trying to keep it beginner friendly just to start at least. Before we start with the actual topic of the demo, I thought it would be good to maybe clarify some of the confusion a lot of people would generally have with these three terms that you see: AI, ML, and data science, right? So a lot of people use them interchangeably and you may not sure what the difference is. So I thought it'll be good to at least start with trying to dissect what these are and at least give you a sense of how they relate to each other and what they actually mean. All right. So maybe let's start with AI, artificial intelligence, right? So I'm sure everyone has heard of this term by now. It's pretty much the buzzword in the last couple of years. You have ChatGPT pretty much taking over the entire world, right? So artificial intelligence is everywhere. So what we mean by artificial intelligence is sort of there in the name itself, right? Intelligence, when we say, we're talking about the human intelligence, but we're trying to make it artificial. That is, we're trying to put that into computers. Simply put, we are just trying to simulate this intelligence that humans have into machines, right? So that's essentially the idea here. And common examples of something I'm sure everyone's using already. So virtual assistants, for example, whether you use Google Assistant or Siri on iOS, etc. They're all AI systems in the background, right? And even say self-driving cars that have started coming up. So they are also AI systems at the end. So AI is essentially the all-encompassing term of data science and machine learning. We'll see how this relates in just a bit. All right. So that's the core aim of artificial intelligence. So it's intelligence but artificial, right? So that's what we mean by AI. Coming to ML, so ML is more of a subset. It's a more of a specialized track within AI. So ML and AI, they're generally used interchangeably, but they're not exactly the same thing. So ML or machine learning is kind of like a subset of artificial intelligence. It's a specialization within that. And the core aim of ML is basically developing algorithms, right? So you have some data, you want to understand some patterns out of the data and gain some insights out of that. That's what ML is. So you're trying to build these algorithms that can automatically learn from the data that you have and give you some insights and like give you some output based on that. That's what machine learning is all about. Again, it has an overlap because it's a subset of AI, but still quite different in the way you generally see it out in the world. All right. And finally, data science, right? So data science and machine learning are probably the most confused terms that I keep hearing. So data science is the process. It's essentially everything we do to get value out of the data that you have. So it's essentially the science part of the data, which would involve ML, which would involve AI as well, depending on what you're trying to solve. All right. So it's the entire process of taking the data, sort of processing it, analyzing it. So statistics is a big part of data science. Mathematical equations generally are also part of data science. Visualizing the data, trying to understand it, and finally generating some insights out of that data. that entire track or that entire path is what we generally term as data science, right? So to sort of make the visualization a little easier, I've sort of put together this, which hopefully gives you a how each of these three relate to each other. So, like we said, ML is a subset of AI. It has other things in it, like for example, computer vision is part of AI, which we don't involve as part of machine learning. And data science is sort of the process, so it has overlap with machine learning and AI as well, but it's still not any of the other. So this is how these three terms sort of relate to each other. Hopefully, if there was any confusion before, I hope this sort of clarified that. So AI is basically the bigger piece of everything that you generally hear. Machine learning is very specific area of of AI, and data science is a process which could be ML or which could be AI as well, depending on the problem that you're trying to solve. All right. So with that, we'll do one more exercise on this, which is about the careers, right? So we sort of understood what each of these three mean and how they relate to each other. But along with that, I thought it would be good for you to give an introduction about, because probably a lot of you are beginners and looking to sort of break into the industry, it would be good for you to understand the various kinds of roles that you would generally see. So that's what this is about. So we'll see the roles that you have in AI ML and data science separately. And I'm grouping AI ML together because as we saw, AI, AI is basically the larger superset. So it sort of covers both. And within AI ML, generally you see these two job roles being very common. So you have an AI or ML research scientist, and you have an AI engineer or an ML engineer. So these two are very common like roles that or job descriptions that you generally see. And the difference between that is basically the kind of responsibilities that you have in each of them. Engineer is probably very easy to understand for everyone. So this is where you are writing code, you're building applications, and you're deploying them into production, right? So engineer is basically taking your application all the way to sort of production, and you understand the system design, how your application should behave, how it should scale, things like that. So that's what an engineer does. While the research scientist is basically the role that sort of like a precursor to engineer. So someone has to build a model that the engineer actually deploys into production. So research scientists are those that are generally doing research. So these are, you can sort of think of as people in white lab coats essentially. So they are in their lab, sort of looking at data and trying to figure out various ways and various approaches in AI and ML, trying to build various models or even try to develop various new algorithms as well for the problems. So that's what the research scientist role is. The outcome of that is generally some sort of a model that they build, and that's what the ML engineer sort of picks up and then puts it into production. So that's how these two careers sort of link. And in general, whenever you hear machine learning or even data science, which we'll talk about in just a bit, being offered as a job description, almost 90+% of the time, what they're talking about is an ML engineer, right? So they want an ML engineer in your team, but yeah, maybe they aren't sure about the difference themselves, or they're just trying to catch everyone with that term. So whenever you hear the term data scientist, or an ML engineer or just a machine learning role, it quite often turns out to be a machine learning engineering role, okay? Where you still have to understand the concepts of machine learning, but you're probably not developing algorithms, but you're just using what's already available. You're coding and you're building applications. So that's what an engineer role here would be. And coming to data science, the most common obviously is data scientist. And along with that, you have a data engineer role and data analyst role as well. So data scientist, like we said, is basically the process part of it, right? So whenever we say data scientist, there is an overlap with the ML engineer role as well, where you take the data, try to understand it, and try to sort of generate insights out of the data. So a data scientist is generally good in mathematical disciplines. So they're good in math, they're good in statistics, etc. So that's what a data scientist career sort of looks like. And then data engineer and data analyst are slightly sort of moved out of data science in regular speak. So a data engineer role, there is no machine learning involved. So in data scientist, obviously there is AI and ML involved, but in data engineering, there is generally no ML involved. What you're building is an application that kind of takes data, does something with the data and puts it somewhere else, right? So you're essentially building what are called as data pipelines. So that's what a data engineering role is. There may be some machine learning roles, but generally very minimal. And that's why data engineers can be sort of like equivalent to machine learning engineers if there is that machine learning piece in the role. And finally, data analyst is sort of like an odd one out of this. It's a combination of technical and maybe a little bit of non-technical as well. So this is the kind of folks that look at the data, generate graphs, charts, things like that, with the purpose of showing it to like upper management, like customers, things like that. So that's what a data analyst, again, very little or maybe no ML in that role as well. So these are generally the terms, like the roles that you see in this domain. And again, the idea here is once you know what they are, whenever you're looking for a career change in the future, you know what you're specifically looking for. So AI ML engineer is pretty much is most likely the common one that you will find everywhere. Even if they name it something else, they're probably looking for an AI ML engineer in general. All right. So that's what the careers you could expect. And these are obviously all technical ones. So non-technical could be data science, product manager, machine learning product manager, release managers, things like that. Those would always anyway be there. And you can also have like system architects, for example, on top of this. But these are the core machine learning related or data science related careers that you see in the industry. All right. So with that said, so this again is just to give you a background of what to expect. Like once you sort of learn and decide what to do after. With that said, we'll sort of get into the actual topic of the demo for today, which is classification, right? So classification is one of the core parts of machine learning. And again, but because this is something we're keeping beginner friendly, we're not going to look at any code today. In a regular class, we will do code examples. We'll do sort of like theory and code in parallel. And we'll also let you code in the class. So whenever we do that, but for this demo, it's going to be only theory. Just so you sort of go through the topic and you can see what classification is and you get a sense of how a regular class here would look like. All right. So the topic we're doing is basically classification, right? So I found this sort of a code that sort of simplifies what classification is all about, right? Classification is kind of like putting a puzzle together. So you're grouping various things together. So the final thing that you have actually has a meaning together. Otherwise it's just pieces sort of scattered around, but by putting them together, you're sort of like playing a detective and keeping all the pieces together. So that's what classification is all about. And that's how we use it in machine learning as well. All right, so let's get to the core of the topic. So what is classification, right? So classification, as you can probably guess from the term, it's all about categorizing. So you have some data, you try to categorize it into various categories or classes as we call them. So you group them saying out of these 10 data points, maybe these 5 belong to one group, these other 5 belong to that other group. So that's what classification is. You're grouping the data or categorizing the data into several classes or groups. Okay. So something like this. Let's say each of these data points we have, and we essentially draw some sort of a line in there saying everything above this line is one category, everything below this line is another category, right? So that's how classification is done whenever you're looking at some data. And how we do that, on what basis we decide which belongs to where, is all about the classification process. Okay. And it's used quite a lot in a lot of domains, and you may or may not even realize it a lot of times, but it's pretty much there everywhere around you, whether it's healthcare, finance, social media, like all of your recommendations, for example. A lot of them are generated through classification. There is another system called recommendation systems. They're kind of different, but classification sort of plays a role in a lot of the domains in the industry today. And a couple of examples that I'm sure everyone's familiar with. So spam filtering, right? So whenever you open maybe your Gmail, Outlook, whatever you're using, you always have this spam folder. So the email server that you are using is automatically trying to guess whether the email is spam or not, and if it thinks it's a spam, it automatically puts them into the spam folder for you. So that's a classification. You're classifying an email as spam or not spam, right? And similarly, fraud detection that bank accounts generally use is also part of this. I know we have a lot of folks here that are from like sort of went out of India to other countries, right? So a lot of you may have this experience where you have a card, maybe a credit card or a debit card that you use in India, and maybe you went out to a different country. The first swipe that you do, or the first transaction that you do with the card, a call comes to you from the bank or a message comes to you saying, suspected fraud, right? That is what the bank is doing internally. It is a classification. It knows about you a little bit. It knows about your buying patterns, and it knows about where you generally buy. So if you are suddenly buying in a different country, it assumes that it's not you, and someone is trying to sort of pretend you as you, right? So that's fraud classification. So the moment you make a transaction, it's trying to determine, is the transaction real, something that you would do, or is that transaction someone trying to pretend to be you, right? So is it a fraud? So that's again a classification example. So these sort of things are there everywhere around you. And so classification is very common that we do in machine learning generally. And even advertising, right? So that's also classification. Why should you be shown ad of this particular company or this particular brand, right? That's also classification. So based on your usage patterns of a website or maybe YouTube, whatever that you use, it knows a few details about you, and based on that, it tries to categorize you into a few categories, right? Maybe you're into sports, maybe you're into music, maybe you're into politics, right? So depending on your interests, it tries to recommend ads for those products or companies, and that's again a classification at play. So all of this basically are different ways, and healthcare is again quite popular where you'd use classification. So it's not as prevalent yet because the chances of mistakes could cause a lot of problems there. But in a lot of places, we're still seeing automated health checks where like you look at your X-rays, MRI scans, etc. A machine learning model can automatically look at them and try to identify a few things before an actual doctor ever gets to look at it, right? So that's also classification at play. So all of these are various ways in which you see classification all around you. And coming to classification, there are two main types that we generally talk about. So one is binary classification, the other is multi-class classification. So binary is what we have been talking about so far, classifying something as yes or no, right? Spam or not spam. Like that would be a binary choice. So, and then again, fraud or not fraud. So that's again a binary choice. So that's a binary classification. A multi-class classification is where you're not classifying into two categories, but rather multiple categories. It could be something like you have a picture of an animal, and then you are trying to classify which animal that is, right? Is it a cat? Is it a dog? Or is it a monkey? So that would be a multi-class classification because the output categories are multiple. It's not just two. So if you have two categories, it's a binary classification. If you have more than two, it's multi-class classification. Right, so examples like we saw spam, basically classification of spam or not spam, that would be binary. Multi-class classification would be where, like we said, you have an animal and you're trying to predict which animal that is. That again would be a multi-class classification. All right, so that's about what classification in general is. So when we do classification in practice, right, we build something called as a model. So a model you can think of as basically a system that does the classification. It takes the data, and the output of that is the data being split into multiple categories, right? So that's what classification is. So we call that system a classification model. Now, ideally, you want the classification to be done perfectly, right? So let's say you have 100 spam emails, then you want all 100 of them to be always classified as spam, and none of the other ones which are not spam should ever be classified as spam, right? So there should never be any issues with that. But in reality, that's never going to happen, right? Because you always have some errors everywhere, and that's where the evaluation comes for these models. So whenever you have a model, you always want to understand, is that model good, right? And just saying it's good isn't enough. You should be able to quantify it. You should be able to say with some numbers that this is better because of this particular number. Or maybe whenever you're comparing two different models or two different systems of classification, how can you say one is better than another? That's again a quantitative comparison where you sort of try to see what this model is doing and compare the performance of that to this other model, and then you will say that based on this comparison, model A is better, or maybe model B is better, and so on. So doing this analysis, doing this comparison is done using evaluation metrics, right? So one such tool that we use in classification is called a confusion matrix. So a confusion matrix, like we said, is basically a tool or maybe a technique that we use to determine if the model that we have, the classification model, is it good, right? How good it is. To evaluate that, we use the confusion matrix. Now, the term confusion matrix may be slightly confusing of its own, why we call that, right? Now, the reason for it is actually very straightforward. So the first part of matrix should be clear. It's a matrix that we will see. Now the confusion is basically where the model fails to classify it properly, right? Let's say you have a spam email, but the model thinks it's not spam, so it puts it into your inbox folder. Or maybe there is a transaction that you did which is valid, but the model thinks it's fraud, so it alerts the bank that it's a fraud transaction. So those would be confusions, those errors that the model does. You can say the model is confused as to what it should actually do. So confusion matrix is just a tool that shows the confusions the model has basically been through. So it shows the errors that the model has. So that's what it is. And confusion matrix is generally a square, or rather a matrix, showing the following four things. So this is what a confusion matrix looks like, the one on the right. So you have true positives, true positives, true negatives, false positives, and false negatives as part of this confusion matrix. So you can sort of see that from the picture we have on the right over here. So we have two axes in a matrix. It's a two-dimensional structure. So we have two axes. We have the horizontal axis and we have the vertical axis. The horizontal axis, which is what you see over here, is the actual class, meaning what is the actual data that you have, right? Is it actually spam or is it actually not spam? Is it fraud or is it not fraud? The actual values. Now the one on the right, so one on the left, which is the vertical axis, is the predicted class. That is, what are you actually predicting that as? It's a spam, but are you predicting it as spam? It's not a fraud, but what are you predicting that as? So the actual values are represented on the horizontal axis and the predicted values are represented on the vertical axis. Now you have two, let's say this is a binary classification, right? So you have two options in both the cases. So that leaves us with four total categories in a confusion matrix. So these are what we give the names: true positives, true negatives, false positives, and false negatives. So these terms may be familiar because we use them in regular conversational English as well. True positives are those that are actually, so here where let's say the two classes are yes or no. That is it a spam? Yes or no. Is it a fraud? Yes or no. So that's what the classes are. That's what the yes and no are representing here. So true positive would be when the actual data point or the transaction that you're looking at is fraud and your system classified it as fraud, right? So the actual value is yes, you've predicted yes. So that would be a true positive, which is correct, right? You want true positives in your system. And similarly, true negatives are those where it is not fraud and you have classified it as not fraud, right? So that's again correct. So that would be your true negative. So these two, both of them, which are represented here in green, you want them in your system. You want to be to accurately give positives for positive values, and for negatives you should accurately give negative values as well. But like we said, there are always going to be some errors, and those errors are the red axis or the red diagonal that you see over here, where the actual is one value but you've predicted a different value, right? So let's say the actual is no, but you have predicted as yes. So that is, it wasn't a spam email, but you've classified it as spam and you moved it to the spam folder. That would be a false positive. That is, you thought it was a positive, that is, you thought it was a spam, but it's not. So it's a false positive. And similarly, the other side of the equation, where it was actually spam, but you thought it wasn't spam and you put it out into the inbox, right? So that's a false negative. So the outcome your model gave was negative, but it was false. So that's a false negative. So a good model, you want more true positives and more true negatives, and less number of false positives and false negatives, right? Ideally, you want 0 for false positives and false negatives, but that doesn't really happen. So generally, you want very less in the red diagonal, and most of your data should be in the green diagonal. Okay, so that's what the confusion matrix essentially shows us. So whenever you take a classification model, you can build a confusion matrix out of that. And in fact, we'll take a look at an example right after this. That will tell you whether your model is doing well or not based on how each of those sort of get mapped into these 4 squares that you have. Okay. One more example that I saw would be sort of interesting. Hopefully that will make it much easier to understand. So take a look at it, go through that and see if that makes sense. What true positives are, what true negatives are, false positives and false negatives. So maybe we'll pause for a few seconds here just so you can read and understand that. All right. So I hope the definitions transfer just as well. So it's always sort of like a representation comparing the actual values and the predicted values. So that's what you're predicting. And you never want, yeah, we got a couple of one question just sort of talking about the squares in the confusion matrix. So yeah, let's do that once again. So let's go back to this one. So in a confusion matrix, again, this is considering it's a binary classification. If it has more classes, it's a multi-class classification. You would have maybe a 3x3 matrix or a 4x4 matrix, depending on how many classes you have. But here it's a binary one, so we have a 2x2 matrix, right? So 2 rows and 2 columns. Now, what these two, so when you have 2 rows and 2 columns, so you basically would have a total of 4 possibilities, right? 2 times 2 is 4. So out of these, so you have 2 possible values for actual, so that is yes or no, that is it's a spam or not spam, the actual value. And then you have 2 values for the prediction as well. That is, are you classifying it as spam or not spam, right? Or fraud or not fraud. So the combination of all of these would give us 4 total values. So if it is yes and yes, meaning the actual value is yes and the predicted value is also yes, that is the email that you got was actually spam, right? So no Nigerian prince is not, they're not giving you $1 million to save your money. So that's a spam email. So it's actually spam and your system has classified it as spam. So that's a true positive, right? It's a good thing. And similarly, true negative is you got an email maybe from your company asking for some details, and that's not a spam email, right? You want that email in your inbox. So it's not spam, it's a proper email, and your system also had classified it as not spam, right? So that would be the true negative, where the actual value is no, that is not spam, and your prediction is also no, not spam. So true positives and true negatives are where your model has done a good job, right? So you want that in your model. Now, the other aspect of this are your false positives and false negatives, where the actual value is one thing, but you have predicted as the other one. That is, it's not actually spam, but it got classified as flagged as spam and it went into your spam folder, right? Again, it's something all of you have sort of faced, where some important email you never got to see for several days because it sort of got flagged as spam and it went into your spam folder, right? So those would be your negative or red boxes over here. And there are two types of errors, right? Where the actual one was not spam, but you said it's spam. So that is one type of error, which is what we call as a false positive, meaning your model output was positive. That is, you said it is spam, so spam being positive, but it's actually not spam. So it's a false. So it's a false positive. And similarly, it may actually be spam, but your model said it's not a spam. So it just got into your inbox. So you said it's not a spam, so your output was a negative, but it's false. So it's a false negative. So false positives, false negatives are things where your model has confused on what the class should be. That's why it's called a confusion matrix, right? So it's basically an error in the system or in the model, and you don't want them in your model. So you want true positives and true negatives, but you do not want false positives or false negatives in your model. But again, like, you never can have zero of them. So you want to have very little in the red diagonal, both combined, and you want a lot in the green diagonal, again, both combined. Okay, so hopefully that was clearer the second time. All right, and we saw this one already. So true positive, true negative, false positive, false negative. So make sure you remember these definitions, because these are again not specific to data science, because we use them all around in English as well, especially true positives and false positives. So those two are used quite a lot whenever we're talking about things. So make sure you understand the difference between them. So true or false basically tells you what you predicted is correct or not, right? So that should be straight. And then positive or negative tells you what your prediction was. So if your prediction was positive, if it's correct, it's true positive. If its prediction was positive but it's false positive. And similarly, true negative and false negative. Okay, so that's how you sort of remember which one is which. Again, we'll look at some examples. Hopefully that will make it even clearer. All right, so this is where we sort of ask you to try something and see what the confusion matrix for this would look like. Maybe let me set the context here. What we're trying to do here is basically we're trying to build a model that classifies. You have two animals in the system, so it's not spam or not spam, but rather dog or fox, right? So that's the classification we're doing. What you have above in blue are the actual values, and what you have below are the predicted values, right? So you can see here it was dog, it got predicted as dog. Second one as well. Third one, it was a dog, but we predicted it as a fox, right? So similarly, the fourth one was a fox, we predicted it as a dog. So based on this, try to I'll show the confusion matrix looks like, but try to see what are true positives. Again, maybe we say true positive or true negative when the outcomes are yes or no, but here, because the outcomes are a dog or a fox, maybe let's call it a true dog or a true fox, right? So those are the classifications. So true dog, true fox, and false fox. Okay, so those are the four categories that we will have in this confusion matrix. So see if you can try to guess what those values are. What is the value of true dog? That is, how many times did we actually classify dog correctly? So it will be true dog. And similarly, false dog, true fox, and false fox. So try to get those numbers. I'll show the confusion matrix in just a bit. So see if you can think of how many were correct, how many were false overall. And if you want to send out a message, you can just put it in the Q&A directly. We can take a look at that also. But try to picture that how that 2x2 matrix of the confusion matrix looks like. Okay, all right. So maybe let's see what that looks like. And again, the idea here is to draw the confusion matrix, right? Which would essentially show how your actual values, or real as we are calling it here, compare to the predicted values. So hopefully all of you got 2 + 1, 3 correct, right? So we got 2 dogs and 1 fox as correct. So we got 2 + 1 in the positive or in the green diagonal in the previous picture. So that is 2 + 1. So we got 3 correct. But we got 2 plus 1 3 wrong as well. So where we classified 2 foxes as dogs and we had 1 dog as a fox. So we had 3 errors in the model. So we had 2 plus 1 3 errors as well. So this diagonal, let's say the left diagonal, would be the good ones in your model, so which we have predicted as 3. The right diagonal, which is also 3. So our model basically classified 50% correctly, 50% incorrectly, right? So that's how we sort of understand the confusion matrix. So once you sort of understand this, anything you can think of going forward, right? If you have 100 emails and 5 of them were classified as spam, so hopefully you can draw a confusion matrix of what that looks like for any of the email provider that you're using. Okay? So it should be something like this. So this is how we sort of think about confusion matrices, right? So they give you a visual way to sort of see how many times you are correct and how many times you are wrong or confused, right? That's what the confusion term comes from. And one last thing before we sort of wrap up this part of the session is about the metrics, right? So we want to have some metrics through which you could determine whether your model is good or not. So those are what we call as classification metrics. So you use these metrics to tell that the classification model you have is good or not through some sort of a number. Okay, so let's use this confusion matrix as a reference for all the terms that we sort of talk about. So first is accuracy. So this is something that all of us sort of talk about all the time, but when we use accuracy specifically in a classification model, we're talking about the total number of times you are correct, total number of guesses that were correct versus the total number of guesses that you actually did, right? So what we call as the correctness of the model, right? So in terms of the values, if you have to sort of put a formula for it, it would be true positives plus true negatives, because those are the actual correct values in your system, right? You have guessed them correctly positive or you have guessed them correctly negative. So those are all the times you are correct. So true positive plus true negative is the total number of times you are correct, and adding all of the remaining, so true positive, true negative, false negative, all of them are basically the how many times you guessed. So number of correct guesses divided by the total number of guesses would be your accuracy. So accuracy, as you could guess, is always going to be a number between 0 to 1, right? The closer it is to 1, the higher the value, the more accurate your model is. So you want accuracy to be good. You want accuracy to be close to 1, or at least like if you're comparing two models, let's say one has an accuracy of 0.6, other has an accuracy of 0.8, then 0.8 is the one you should probably pick, right? So that's how we sort of think about accuracy. So another term we use is called precision. So in general, maybe in regular conversational English, maybe precision and accuracy generally tend to be overlapped, so you may use them interchangeably. But here, when we say precision, we actually mean something slightly different, right? So here we're talking about, of all the positives that we have actually predicted, what percentage of them were actually correct, right? So all of the positives that you have, how many were actually correct? So for example, if you see predicted yes would be this plus this, right? So true positives and false positives combined together would be all the ones you have predicted as positive, but out of them only true positives are the correct one. So that ratio is precision, right? So again, it's a number between 0 and 1, and you want it to be as high as possible. So precision basically tells you, out of the positive ones, how many times you were correct. When you guessed it as positive, let's say when you guessed it as spam, how many times were you actually correct, right? How many times was it actually a spam email? That ratio or that proportion is precision. So accuracy, precision, different things, right? You want both of them to be high values, but they would have different values, as you can see from the formula that we have over here. And final term that we use is called recall, right? So recall is sort of like the flip version of precision, where you're not looking at the predictions, but rather the actual values that are there. So the actual positives are the first column you have, right? This one. So that's all actual yeses. So actually it was spam, But out of all the spam emails that were actually there, how many did you correctly classify as spam? So that ratio is recall. So that would be the true positive divided by true positive and false negative. That entire column is the actual positive values. So that ratio is what we call as recall. Now, you may sort of try to wonder why we need three different things, right? Why can't we use just one? There are cases where one is better suited than another. For example, think of maybe a medical diagnosis, right? Accuracy is good, you want accuracy, but in medical scenarios, you want precision and recall to be good as well, because guessing, like let's say maybe you're trying to detect whether somebody has a disease or an illness, right, based on the reports that you have, like maybe whether they have diabetes or whether they have cancer or something like that. So based on that, obviously you want, if somebody has cancer or somebody has diabetes, you want to be able to guess that correctly. So that would be true positive. And if they don't, you want that to also say no. So you want that both true positive and true negative to be there. But you also want the errors to be as low as possible, right? You never want someone to think they have cancer when they don't, or you never want to tell somebody that they don't have diabetes when they actually do, right? So you don't want those errors as well in your model. So precision and so accuracy just tells you how many times you're correct. It doesn't matter if you're correct because you have more corrects or maybe you have less errors. It doesn't tell you that information in the accuracy. But precision and recall, because you have false positives and false negatives in the formula directly, that can affect the values of precision and recall. Using that, you can effectively tune how the model should be. So for a specific scenario like the medical scenario that we talked about, you want false positives and false negatives to be as low as possible, so that you want precision and recall to be very high for those sort of scenarios. So that's why we calculate all these three for all classification models that we build. And then we obviously we want all of the values to be high, but how high? Is it 0.8? Are we okay with 0.8, or do we want 0.9 or 0.95? Depends on the field that you are building the model for. Spam filtering, maybe not a big deal, even if a few are wrong. But medical diagnosis or even financial transactions, right? You want there to be as accurate as possible. So their precision and recall should be much higher than for something simple like spam classification. All right. So that's the end of the demo topic, which was classification. So hopefully that gave you a good sense of what sort of like the classes looks like going forward, and also you understood something about this new topic. If there are any questions, we can talk about that now. After this, maybe we'll talk about the code structure as well, if anybody wants to discuss that. So we'll pause for maybe a minute or so. Let's see if there are any questions of anything we talked about, or it could be in general about the course structure, the curriculum, the content, things like that also. All right.
Yeah. Hey, Santosh.
Absolutely. Yeah, this is Santosh. Yeah. Basically, I have a question. So this course is targeting to the what kind of career, basically? Like, so you have told like multiple careers, right? So what kind of career yeah, this course is targeting?
Yeah, very, very good question. So let me maybe go back to that slide just quickly. So the question was basically the codes that we're doing here, which careers are we mainly targeting? So one thing maybe I'll just straight away say, research scientist is sort of like out of the question here, because that has involved background in math, statistics, etc. Same for data scientist as well. So those are not probably something you can definitely try, but the way we are teaching is more practical applications. So it's more suited for AI ML engineers than for research scientists. It has a big overlap with data scientists. So I would say overall, it would be these two careers that we're definitely targeting. AI ML engineer, where you understand machine learning, and using that, you're able to actually build a system that can be scalable and can be put into production. And you also build tools that make you a data scientist. So you can actually take all the way from getting data for a problem trying to understand the data and using that data to solve a problem. So those are the two careers that we would mainly be focusing on. But just to add to that, data engineer, again, I'm not trying to like sort of reduce the effort involved in that, but data engineer is kind of a bonus if you're aspiring to be an AI ML engineer, because the basics of being an engineer and working with data is same as what you would when you have it when you are trying to be a data engineer. So that would sort of also fall into place because we're targeting AI ML engineer. So in that sense, it would be these three. So data analyst is kind of out of question because data analyst is very tool specific. So we are not really touching that. And also research scientist is kind of out of scope for the way we would teach here. So yeah, it would be these three roles that we would target.
Look, there are a few
Okay,
questions.
sir.
Yeah. Yeah, someone's asking industry experience. Yes, so I've been working in the industry for close to 10 years now. I've started as a software engineer, but then progressed into data science like very quickly because our team already had data science as part of that. And then sort of that evolved into a career in architecture as well, me being one of the senior members in the team. So that kind of sort of put everything together. So I'm currently like sort of have a dual responsibility in the team, both as a data scientist, where I lead a team of data science folks in the team. Plus, I'm also a software architect where I build tools and design systems that that go into our components. So yes, long answer short, yes, I've been working for about 10 years so far.
Hey,
And
Saurabh, I have another question. So we understood that this course is better suited for data engineer or ML engineer, AI engineer, right? So if I'm an aspirant AI research scientist or data scientist, can this course be a step one for me?
Yeah, definitely. So because what we're starting is from the basics. So being an AML engineer or being a data scientist is kind of puts you already on the path to be a research scientist with a few more things that you have to add on top later. So you would definitely be on the path by taking these courses. So you could become a research scientist. But yeah, we maybe stop a little short of that, but you are already on the track to be a research scientist as well with these courses that we're taking. Yeah. All right. So someone's asking about prerequisites. So we have different courses. Maybe I'll just quickly switch to that. Just give me one sec. You will have access to this as well, like the entire course material. Maybe some of you have already seen it. If not, it will be available for you through the website, or maybe our team will share it through the email. But let me maybe just open up a list of all the trainings and what we're calling as teaching tracks. So let's see what they look like, and that will give you a sense of where that fits in for each of you. So we are targeting all the way from beginners to experienced professionals. So you can pick whichever one suits your specific needs. All right, so yeah, these are the teaching tracks. And yeah, one thing to sort of keep in mind is the entire curriculum is sort of going to revolve around Python. So someone was asking about prerequisites. So expertise maybe is not necessary, but understanding of Python and definitely some programming language is important. And if it is Python, that will definitely be useful. But if not, as long as you have some background in programming, we do have a course that teaches you Python. So both beginner level and intermediate level. So this track can take care of you as long as you have some programming experience in some other language. All right. So yeah, prerequisite, because we have sort of all the range from beginners to advanced, I guess the only prerequisite is just your enthusiasm and your interest in learning. That's pretty much it. Some programming experience is definitely helpful, but we can teach you that as well as we are sort of taking you through the entire course. So maybe I'll just quickly take you through the the tracks that we have, you can see we have tried to focus specific areas that you would expect in a typical software industry. And that's how each of these have been sort of tailored as well. So first one, as I said, is about all Python. So maybe you have some background programming experience, maybe not, but maybe you don't have much experience with Python. This course would definitely be for you, where we have two sections as part of that, where we have a beginner and intermediate level as well. And we have the approximate hours as well given here. That is sort of like an estimate. But that can be sort of tweaked based on your experience and how quickly or how slow we sort of take it through the classes. All right, but that's just an average of generally what we see. And beyond that, we also have full stack development, which is basically Python plus the ability for you to, so it's not a data science role, but let's say if you're looking to get into a Python developer role, this would be very useful for that. We do teach you sort of basics about data analysis and data processing as part of, but we also gives you tools that you could use for front-end development and back-end development. So that's what we call as full stack, right? The ability for you to build front-end, so web pages, etc., and also back-end, all with Python. So that's the second track. If you are looking to build become somebody who is essentially a Python developer, specifically a full stack developer, right? So that's the second course. And then we sort of start the ML related courses. The course number 3 here is basically data science and ML track. So this is for everyone that, and each of these courses sort of like build on top of the ones before. So this is for somebody that maybe has some Python understanding, although we do have Python beginner course as part of this that you can sort of opt for. But again, these are optional, right? So if you think you're already familiar with Python enough, beginner, intermediate level, you can skip that and straight away get into the meat and potatoes of it, which would be the data analysis course and machine learning beginner course. So that would be track number 3. And finally, this is basically the complete track where you get a sense of from being a beginner in Python all the way to be able to build deep learning models, understand tools like ChatGPT and even use them and try to build tools like that yourself. This sort of course takes you to that entire journey. And these are all the sections that you sort of see as part of that. So this track would be good if you are someone starting out, maybe some programming experience, but you want to sort of take it all the way so you can actually build a career as a data scientist or an ML engineer. Okay, so these are the 4 tracks that we have, and each of these tracks is definitely customizable based on your own experience and your preferences. But generally the times and everything we have given is sort of like a rough estimate based on past experience and what we generally think students would pick. Okay. And we'll make sure this is available for all of you as well on the websites and as part of your email documents as well. All right, I see we have a few more questions. So hopefully the duration we have answered, so that's done. Yeah, someone's asking about prompt engineering. So that's a very specific topic that we'll come to in deep learning. So which is very relevant in the current industry where everything is being generative AI, right? Where you have tools like ChatGPT. So yes, prompt engineering is useful in those cases, but it's a very niche area. If you're never going to work with generative AI, that's not going to be useful. So yeah, someone's asking detailed curriculum. This gives you the full list. And along with that, we also have specifics of what each of these courses covers. So all of this would be made available to you. So this is sort of like the full set, all of it here. So we give you details of what we cover as part of each of these courses as well. That's already there. And are these live classes? Yes. So it would be just a similar setting, but probably with more interactivity and much smaller set of students. So we have, I think today, like maybe 60 or so students on the webinar today, but a regular class will be much smaller, where you will be able to talk and ask questions more freely, and it would be live completely. And along with that, I mean, you probably have seen it in the brochures that we have shared, but everything that we have covered would be shared as part of notes for you. And any questions that you have, we can set up separate one-on-one sessions as well, just to sort of handle those individual questions that you have. So we want to make sure we give you all the tools and techniques so that you are successful in your career there. So along with classes, we have these additional things that we will also share, so that you have everything that you need, sort of to like whether you are looking for a new career or in the same career, so that you are like definitely going to be up there. That's our goal for all of this. And someone's asking, I'm currently working on Informatica and AWS data. So I'm not very familiar with Informatica other than that it exists as a tool for data analysis. So that would be, I think, a role that we saw as a data analyst, right? So data analyst has very little overlap with machine learning or AI ML, but knowing AI ML would definitely sort of give you a better boost, let's say, in any career that you have, because understanding data is the core of all of machine learning and data science, right? And all the careers we talked about revolve around data. So even if you're a data analyst, although you technically don't need any understanding of machine learning, if you are able to get some sense of that, right, data science and some of the techniques that we teach, that can definitely help you in your in your career as a data analyst as well, and that can also give you a boost. Let's say if you want to maybe move from data analyst to a data engineer or even a data scientist, this could definitely pave the path for that also. And yeah, someone's asking about the dates. So we'll sort of publish the dates based on like when the students are available, and same with the time zones as well. Like I was talking about before, we have folks from like 4, maybe 5 time zones that have sort of listed everything here. So we would definitely want to sort of keep it in a time zone that's friendly for everyone. So based on the majority of students in a particular batch, we will have multiple batches going as well. So based on that, we'll sort of pick the time zones, and same with dates as well. Based on the availability of students, we'll sort of like pick the date. But we are looking to start very soon, like maybe mid-May or so, depending on the interest that we have from the students. And the duration, yes, we were just talking about this, right? So depending on which track and which course you opt for, it can be like any of these, depending on how we'll do. And again, these are all estimates. So depending on if we're going maybe a little deeper, or maybe if you're already familiar, the dates, that the time duration can change a little bit. But these are rough estimates that we have. And yeah, one last question that I see is the fee. So that's something we're maybe sort of finalizing over a bit. Our team will kind of share that information with anyone that's looking for that. Our team will get back to you maybe like over call or over email, and sort of like give you a final like a sort of like a quote on which track you're picking and what that would what the fee for that track and course would be. All right, I think at least all the questions that have come up, we have answered everything. Any other questions from anyone? Anything about the teaching tracks, the curriculum, the content, or even the topic that we have covered today? Any other questions?
So for like AI and ML, right? So I mean, there are different kind of courses, right? So I mean, if you have given the higher level of the things which you have covered, which you are going to cover, but I mean, if you can give what are the things you are going to cover, I mean, in deep, right? So that would be great.
Yeah, so that would be part of this document that we will share, but maybe I'll just quickly flash that over here so you can see what we would cover. So this is the machine learning course. So I'll just quickly sort of keep going through. You can take a look at, and for example, classification is the one that we covered today. So it would be, it would sort of fall under this. And we talked about this today, right? Evaluating classification models. So confusion matrix, precision, recall, this would be a part of the machine learning course, along with the coding part of it. So one thing we didn't get to try, because it's not really a place for that today, is coding, right? I didn't get to show any code, but in a class we would do a little bit of both, because just theory isn't really sufficient, because at the end, like we said, it's all about being a good engineer, right? So you want to have practical approach as well. So we will discuss a problem, we will try to see how we could solve it, and we would actually build a solution together in class, and we'll go through the code sample of that and try to sort of fix that. So we will do sort of both in parallel for any given topic in the class, and we could also do where we'll do sort of mini assignments within the class where you can sort of try something yourself, and also have post class quizzes, assignments, etc., where you can sort of relearn and sort of assess whether you understood something properly or not. So that's something you would have as part of your regular classes. So these are the topics for machine learning. One more thing we have is data mining that we didn't get to talk about today much. Also ensemble learning, and then coming to deep learning. These are the topics that we would be covering. Yeah, and the question that somebody had about prompt engineering sort of falls under this, which is large language models, which is basically what ChatGPT is all about. So we would actually sort of try to understand how ChatGPT works as well as part of this section of the course. So yeah, these are the topics. Again, it may seem too much, or maybe it's probably not clear right now because you may not understand what these are, but I will make sure these are available for you. And as we go through this, all of these will make sense pretty quickly.
Yeah. So if someone is asking about conclusion.
Yes, yeah, iron and CNNs, yeah, that's what I was just showing here. So those would be necessarily definitely required as part of RN. Yeah, so these are the topics that we would have. So we will cover traditional neural networks, but we'll definitely build CNNs and RNNs in the class.